Hi everyone. More technical things dealing with the system unit. This term is probably a little more generic. Some people would view it a little bit different than others, but in most cases a system unit is thought of as the main area where the work gets done in a computer. A lot of times you'll hear the term motherboard. There is some type of circuitry that moves information throughout the inside of the computer. Okay, let's talk about some of those key areas inside there. We've already mentioned memory, RAM, cache, ROM, flash memory, and so forth. So let's try to clarify that a little bit more. Inside there is a processor, and that processor has registers, high-speed staging area, places inside the processor where information can, or data and information can be used in the processor in order to do its work. This is not the registry in Windows. It's completely different. Registers, high-speed staging areas in the processor. That's really about all you need to know about that. Remember, we already talked about the word size of the processor. For example, nowadays, a lot of them are 64-bit word size. 64 bits they can process. The arithmetic logic unit does this. It decides if two things are equal, or if something is greater than, or something is less than. So what does it look at? It looks at bits. So it decides if the two bits are equal, if one set of bits are greater than the other, based on binary, or if they are less than the other, based on binary. And then it makes a decision. That's really all a computer can do. It doesn't make a difference how fancy or how crazy and amazing you think a computer is doing something. It's just looking at the bits and deciding greater, less than, or equal. Based on that, the computer does something. You know, it follows the instructions. Okay, just a slight review there. Remember, the instructions, the software is in memory. And then it travels along the electronic bus to move to the processor and send the results back. Performing instructors send the results back. Talk more about that later on. A coprocessor, if this processor is going to be overtaxied, you can have a coprocessor. Some video cards have processors right on the video card. When people talk about a quad core, you know, where you have 4 cores, it's kind of the same thing. Now we have 4 different cores that can execute instructions there, speed up. We have this this electronic bus. Sound funny. Electronic bus that moves the bits internally. And if you have a 64-bit processor, you would have a 64-bit bus. And same thing, there can be more than one bus inside there moving the work. Okay, we can have a graphics card, video card that handles the video, so you can actually have something in there that sends the video from off the bus. You know, you have this really nice monitor or display up here, wherever it is, so it can manage the movement of the information to the display, which will make the display move much smoother. For example, if you're doing some work with graphics or video, or you have a game, if you have a card that will handle the information that's going to the display, it'll make your machine run better. Okay? Now, I'm going to move this up a little bit. Not too far. The next thing, clock speed, gigahertz. Machines are going to be measured in clock speed. How many cycles the machine can run per second. Okay, so in order to take, I'll give you a very crude example. So in order to take, if it's going to execute an instruction, that instruction has to be brought into a register. Instruction has to be processed, and then if the instruction does so, it sends the results back and possibly sends something out to the display. That would be called a machine cycle, and it might take so many cycles to do that. Okay, so depending on the gigahertz, it would affect the performance of the machine. Okay, so higher the better, but we'll make reference to that later on. Like you might have a 3.2 gigahertz machine. So it's doing 3.2 cycle, 3.2 billion cycles a second, or yeah, billion cycles, gig. Does that make sense? It'll take so many cycles. So then sometimes they'll not use much anymore. They used to talk about million instructions per second, how many MIPS a machine would be, millions of instructions per second. That's not used so much. So you have so many cycles in order to execute an instruction, and you have the speed of the machine, and then you can do this. Okay? Now, here's another thing that's extremely important. We'll talk about virtual memory. Okay. Up here we have our memory, but you can take and put some memory on the hard drive and make the computer think it's regular memory. So it's called virtual memory. Since it's on the hard drive, it's going to be much slower to move this information into here because the hard drive has to mechanically spin and so forth. So even though it's milliseconds, it's less than a second, in here things are a nanosecond. Okay? We're going to refer to that one more time in a little bit. So this, you will hear some terms for virtual memory. A swap file, because it swaps information in and out, or you'll hear the term page file. And years ago, you would organize your programs in a way so that it could grab a page here, bring it in, and then work on that page back and forth to the processor. And then when it's done with that work, throw that page out and bring in another page. It's just like your brain can only hold so much, so your virtual memory is on a piece of paper. So if somebody asked you a question like, what's your phone number? And if you couldn't remember your phone number, you could go to the phone book and look it up. But if you could remember it, you could just tell them. So remembering it's like your memory. I'm up here on memory, top of the page. And virtual memory would be like having to pull it off of a book or out of a piece of information. Okay? Computers have ports. I'll use a different color here. Computers have ports. Okay? Like a USB. Video. And these are always improving a lot as years go on. Okay? They're always improving a lot. We already mentioned like a FireWire and so forth. So the ports can be built in, or in some cases, if you want to add something, there can be a slot and you can add a card that would create a port. Almost all computers nowadays, not all, but almost all, would have a network port. Let's mention that. I'm going to scroll this up. So they could have a network port, which would allow you, it would be an RJ45, which would allow you to connect a network cable to that port. Alright, got to finish. This last thing is performance. So we have our system unit, and then we have a hard drive. I should say we have the motherboard, and we have a hard drive. A lot of times this whole thing is in one, like your PC. Okay. What affects performance? Let's go to the key thing first. Information internally moves through the bus extremely fast. Okay? You've got your memory and your processor, and this communication has to occur in order to process a program. And this doesn't make a difference if it's a computer, your phone, a device, in your car, how it's communicating. The connection here, okay, though fast, is slow compared to the connection inside here. So as memory fills up, the computer starts to use virtual memory off the hard drive, which is slow. So if you want good performance out of your computer, it's important to have as much RAM as possible. Some people will say, well, that, your clock speed is also important. Well, it is, but in a lot of cases, if people have I'm just making one up, 2.4 gigahertz clock speed, it's pretty hard to keep that busy based on the fact you have to be moving things around in the computer, especially the quad cores. So what's really important is that you have enough memory in your device or your computer so that it doesn't, in a computer, so it doesn't have to swap out. Now if you have a device, you might have to close some things in order to free up RAM, like on your smartphone. As memory gets full, it won't perform well. But on any laptops or PCs or computers, as you fill up memory, you're doing something like has a movie or lots of graphics or you're editing something, having lots of RAM will help the performance of your machine. Okay, and that is it.